The next team to present is JBD USM from USM. You may proceed to the front to begin your presentation.
Honorable judges and also all the participants here. And today, our group JBD USM, and J stands for Mr. Ng Jing Shen, B stands for Mr. Brian, and D stands for me, Mr. Denson. So the topic that I'd like to touch on will be zero waste management on volatile fatty metal distillate produced from vacuum system in palm oil refinery plant. So just for your information, we already make an effort to visit the factory itself and interview the manager there to get a clearer picture about this. And we already brought back the samples here as well. So would you please have a look, and if you can, just take a smell of it, okay? And so moving on to the next slide. So what is volatile fatty metal distillates, or in short form, VFMD? It contains 90% of fats, volatile metals, and also it has coloring pigments. And it has high order pigments, and it contains a lot of impurities. And these distillates come from two sources. First is from the hot well, second is from the cooling tower. So for the hot well, the distillates is grayish in color, or I can say dark gray. And it's from the cooling tower, it's in brownish color, and it's also in solid form. So VFMD is a waste. So of course there has a problem statement as well. And for the problem statements, first it causes blockage to the pipes. The waste will stick to the inner lining of the pipe itself and will form a blockage. So, and this will cause a lot of, can say, various losses as well. And the side problem will be, we interviewed the manager there, and they say they have quite an improper way of management of the waste, and also the waste is a type of scheduled waste. And scheduled waste, of course, can cause pollution as well. So how to overcome this? I would like to invite my partner over here, Mr. Brian, to further explain about it. Thank you.
Hello, and very good morning. And next, we'll discuss about the strategies and also implementation of our concept to our idea. And of course, as you can see in this diagram, we suggest to install a fat trap tank at the above of the hot well and also the cooling tower. And the fat trap tank is like this. This is just our example of our ideas. And we can apply the enzyme dosing system inside the fat trap tank for the further breakdown of the fatty matter into simpler substance. After that, the treated VFMD can be used for composting because, as we all know, the fatty acid has the greater extent of decomposition if compared to other type of solid industrial waste. And if it is modified into a combustible fat fuel, it can be used to generate energy through incineration. Then, due to its high order pigment inside the fatty matters, it can use to produce a product that can use other unpleasant smells like a solid soap gel, which coated with the activated charcoal. And for the last one is the fatty acid metal ester FAME. This is because due to it has a similar properties with the PFAD palm fatty acid distillates, and it can be used to produce the deodorant, nail polish, detergent, biodiesel, as of course the biodiesel as the core product. And last but not least, impact of our concept is first, the way of management is not just limited to what we mentioned earlier. And it can be incorporated into many fields as it has a very high potential for the future research and also the projects. And if you use the way we suggest just now to manage the waste, it can save a lot of costs. And of course, the product produced is environmental friendly and economical valuable. And last, I hope that our suggestion can be the reference for future exploration of solid waste management in palm oil refinery plant. That's all from our group. Thank you very much.
Okay, thank you very much. Another interesting idea. I just want to again clarify, the current situation is that you have these basically solid wastes. So now what you want to do is you want to treat the water before it goes into the cooling tower and into the hot well, or
no.
what is your?
Our suggestion is just now, as you can see in the diagram in here.
Mm-hmm.
We will collect it first, and after we collect it inside the tank, and it can be further used.
Okay, but what's the difference of collecting before and after?
Oh, before the management is like just some they will simply use the manpower to collect it
Okay.
compared to this one.
Okay, 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 good, good. So, um, we can go to the next slide. So you have these various options.
Yeah.
Have you looked into, for example, in terms of composting? So these are basically the two products you're then going to take for.
No, this
for
is the waste product.
But how would this look differently if if you take out before? So treated, the treated volatile fatty methyl. What was the sort?
Volatile fatty matter.
Yeah, what's the fatty matter?
Distillates. Yeah.
How would the treated look differently than this product?
The treated one is we didn't bring here because it's still in the progress
Okay.
of the company. Yeah.
Okay, okay. But the main difference is that is taken out before it goes into the hot well and the cooling tower, and this one is after the hot well and
Yeah,
the cooling
after
tower.
the-
Okay, so that's mainly the only difference. So you'd expect that the treated one would be similar to this, or is it going to be very different?
For our idea is a bit different because this, if you see from the cooling tower, there is contain some liquid inside, but from the
Okay.
the other one is the dry one. So after treated one, the liquid one will be more dry, just like the drier one.
Okay, okay. So in terms of nutrient contents and all, for example, if you want to do composting, is it comparable to you can say regular conventional compost?
Pardon? Is it mean the
I mean,
properties?
is it will the compost? Will this, one thing is you can compost it, but it's enough nutrients inside. If it's just some fatty matter, is there actually going to be nutrients inside, or is it just you say fat without much?
I think there's no much nutrient inside because it is like it's a type of waste because it's already mixed with certain just like a sludge like that. Yeah, solid waste.
Okay.
My concern is on the economics because your VFMD production is only 1 ton per month. So whatever system that you're going to have, whatever process you're going to have, the volume just too small for you to make a commercial conversion of VFMD to whatever it is. So have you looked at the economics of it?
Yeah, for the economic, I know it's quite low if compared to other waste, especially like the decanter cake or from other waste from the bleacher and the deodorizer and also the refinery plant. But if 1 ton, if you can, there is only need a very small amount if you want to produce the product, like to mask the unpleasant smell because it's already contain a very high order pigment inside. So compared to other, you need the higher amount of the waste to convert it into a product, but this only need a very small amount to convert the product. So I think even though it's not much economical valuable compared to other, but it still have its own economic value.
Interesting ideas, guys. Interesting ideas. My concern is, of course, there are legal implications in dealing with this waste, so you should take that into account in your benefits. Yeah, not only it reduces the cost of waste disposal, but also it resolves some of the operational problems in the operation. Yeah, thank you.
Okay, thank you.
And he's going to be doing as a composter and not much nutrient into it. Even plants want some nutrient, isn't it? I mean, if it's just a blob or what do you call it, just a material without nutrient inside it, I think composting needs some kind of whatever inside it. Is it just material raw, nothing, just a biomass like that?
Oh no, because just now, as we mentioned, the properties is about like 90% of the fatty acid inside. So the fatty acid has about 10-fold than normal condition for the composting. The fatty acid content inside it. is very suitable for composting due to its fatty acid content because it's like for its biotransformation, it had a correlate to the composting parameters for the temperature and also the time for it.
Just go back to the other one again with the solutions. The next one. For all four basically. I mean, have you looked into the actual feasibility of each of these four, or is this an idea? This is your four ideas, but you have looked into the actual feasibility. How well suited are these four, and is there one of these four that could be more suitable than the others, for example? I mean, is it better to use as combustible fuel, or better to use as composting, or better to use as FAME, or which solution would you think is best?
Actually, we still haven't know which one is better yet, but it's still in progress.
Okay.
I mean, yeah.
Okay, thank you.